So last class now we can discuss about attenuations. When fiber, so there is a possibility of two cases. So one is called a signal attenuation and one more is called a signal distortion, or we can say dispersion. The attenuation means there is a complete loss, there is a fiber loss. So to avoid that, to overcome that, to eliminate that, what we are doing, we are using optical amplifier such as erbium doped fiber amplifier, or we are using regenerators or repeater. So based on signal loss or based on signal strength only, we are deciding the repeaterless transmission as well as the amplifierless transmission, as well as how much distance we can transmit, how much distance we can offer between transmitter as well as receiver without using the repeater. Since the cost of repeater or regenerator is very high, so by maximum we have to reduce the fiber loss. The fiber loss mainly happens due to attenuation. So attenuation means, what is attenuation? Attenuation means it is a signal loss. For example, a loss of signal strength in a light wave, that is electrical or radio signal, usually related to distance of the signal travel. Determines the maximum transmission distance between transmitter as well as receiver. The attenuation happens due to material attenuation, bending, that is micro bending as well as macro bending. So material attenuation, we can say absorption as well as scattering. So this is the basic classification about attenuation. So this is the main classification, important. So attenuation we can classify into three categories. One is absorption and one more is scattering loss and one more is bending loss. So in absorption there are three areas, that is three classification. One is due to atomic defect, and second one intrinsic absorption, and third one extrinsic absorption. So scattering loss, there are two reasons. One is infrared region absorption, and extrinsic absorption, it happens only due to impedance. And third one is two molecules density variation, because of that there is a possibility of absorption. So intrinsic absorption, it is due to pure fiber material. Extrinsic absorption means due to addition of impurities like OH ions and another impurities we are adding to manufacture the fiber. So because of that there is a possibility of absorption, that is called extrinsic absorption. Scattering loss, we know that scattering means spreading of the signal. Normally if you are transmitting any optical signal, it should confine through only core medium. But due to some imperfections, due to some defect in fiber, or due to some compositional fluctuation, not all the light pulses are traveling through the fiber. So because due to some variation, due to some defect in fiber, some of the light pulse, that is we can say lower order modes, higher order modes. So some higher order modes are at the edge of the fiber, it is core and cladding boundary. Because of that there is a possibility of spreading. In that spreading, some of the light pulse will enter into the cladding and it will radiate into the cladding. So that will produce a scattering effect, that is called a scattering losses. So scattering, there are two types. So one is based on linear scattering and one more is based on non-linear scattering. And the last one, radiative loss or bending losses. The bending loss means there is macroscopic bending as well as microscopic bending. So macroscopic bending means the bending, if the bending radius is greater than the diameter of the core, that is large bending, that is called macroscopic bending. So macroscopic bending will leads the effect of loss, because if you are transmitting any light pulse, so electric field distribution, majority of the light it should confine along the center of the axis, but due to bending effect, so center as well as edge, center can follow the bend effectively, That is, the velocity can follow the bend, but the edge, these higher order modes, when we compare with lower order modes, the electric field distribution is very less in higher order modes. So what will happen means it does not able to follow the bending. So there is a possibility of signal loss. That is called a macroscopic bending. Microscopic bending means small bend. That is, the radius is compared very small diameter. So it happens due to imperfections. This is practically negligible one. So microscopic bending can be eliminated by using some protection, some outer jackets. By doing that, we can able to eliminate the microscopic bending effects. Okay. So we know that attenuation, very important criteria for designing the optical communication system. So attenuation only defines the maximum transmission distance between transmitter as well as receiver. So suppose if I want to increase the distance between transmitter and receiver, we have to reduce the transmission loss. That means we have to reduce the attenuation of the fiber. For example, how we can calculate means we take PI is the input power, PO is the output power. So loss we can say 10 logarithmic function of Pi by P0. So this is the formula for determining the attenuation. Alpha dB decibel length is equal to 10 log Pi by P0. Alpha dB means signal attenuation per length. L means fiber length. So this is a formula used to find out the attenuation. For example, this is fiber cable. Z is equal to 0. That means distance. Here Z is equal to L. Initial power is P 0 milliwatts. And final power is Pi, that is P0 into e power minus alpha P into L milliwatts. Here alpha indicates propagation constant. So P is at signal if it is traveling along the Z direction, then P is equal to P0 into e power minus alpha P is at 8 milliwatts. So this is a formula for finding out the power. Here alpha attenuation coefficient. For example, if L is equal to 1 kilometer, alpha we can define. That is 4.34 alpha B. That is the value of alpha in decibel. So attenuation we have to denote dB. This is a common unit. We have to follow that. We take one problem in that there is a 30 kilometer optical fiber as attenuation of 0.4 dB per kilometer at 1310 nanometer. Find out the output power if 200 microwatts is the optical power launched into the fiber. So we know that the formula power in 10 log 10 output by inputs. So 200 10 power 6 1 into 10 power minus 7 dB. So this is the, so we have to express the final answer is 12.6 microwatts. So absorption, this already we have seen. So there are three. One is that is atomic defect, intrinsic, extrinsic. Atomic defect due to missing molecules. Intrinsic, ultraviolet region, IR region. Extrinsic due to impurities. Atomic defect, three reasons. One is missing molecules. Second one, density cluster. Third one, axis defect in class structure. This is happens in atomic. Intrinsic means this is happens only in pure silica fiber. So we can have the three window, that is 850 nanometer, 1310, 1550. So the graph indicates the wavelength versus attenuation. This and all we have seen already. Intrinsic absorption happens only due to pure material. This and all we have already discussed. Extrinsic absorption, it is much more significant, much more large when we compare with intrinsic because of addition of impurities. There are two, one is called metallic ions, one more is called hydroxyl ions. So this is the impurities we are adding. Because of that, there is a possibility of absorption that is nothing but extrinsic, that is metallic ions, iron, nickel and chromium. That is called extrinsic absorption. OH ions also causes extrinsic absorption. So this is the extrinsic. This is the graph indicates the attenuation versus wavelength. this is a common graph. The first window, second window. Okay, so this is about absorption and signal dispersion. In conclusion, we can say that absorption, that is attenuation, occurs at absorption, and dispersion, it is a error. Attenuation means, so there is a signal loss. Distortion means there is a pulse overlapping. Because of that, error will be produced in the receiver. So attenuation or fiber loss we can able to eliminate by using repeater as well as optical amplifiers. But the error, that is due to error produced due to signal dispersions, we can able to reduce only by the receiver. After receiving the signals, by using some techniques, some methods, we have to recover the original signal what we have transmitted in the transmitter. Okay, so this is about attenuation as well as distortion, or we can say dispersion. So in unit number 2, till now we have discussed about various attenuation mechanisms like absorption, and next one various losses like intrinsic absorption, extrinsic absorption, atomic defects, then scattering losses, that is linear loss as well as non-linear scattering as well as non-linear scattering, and macroscopic bending, microscopic bending as well as core cladding losses. These are the losses. And dispersion, we have seen intermodal dispersion, intramodal dispersion, polarization model dispersion. So this is about the transmission characteristics of optical fiber. So next class we will discuss about index as well as grading fiber losses as well as group velocity and group delay parameters in step index, single mode, multi-mode as well as grading index fibers. Okay, thank you. So at the in between the PowerPoints, so there is a quiz I have added. So kindly complete the quiz and give the response. So based on that only attendance will be provided. Okay, thank you.